Hello everyone. We are going to look at the problem. So here is the problem statement. Given an array of size n and the array elements, we have to print all the unique subset in sorted order. So here is the constraint, like the size of the array can be 10 power 6 up to 10 power 6. Any array element can be up to 10 power 6. Also, it is given that the sum of all the array element will not exceed 10 power 9. Okay. So if we add all the element, the sum will not exceed 10 power 9. Now let's say if our sample input is 1, 2, and 6, 3 is the size of the array, and 1, 2, 6 are the elements of the array. So what are all the subsets we can generate using these three numbers 1, 2, and 6? We have to print the sum of that in sorted order. So let's see how we can solve that. Yeah, so we'll take this example. We'll take the same example, 1, 2, and 6. Yeah, if I ask now, what are all the subsets of 1, 2, and 6? Let's try to write all, okay? So 1 is empty subset. Then let's take all the subset of size 1. So we'll get 1, we'll get 2, we'll get 6. Yeah, let's now take the subset of size 2. So 1, 2, 2, 6, and 6, 1. Now we are remaining with one more subset, that is of size 3, that is 1, 2, and 6. Yeah. So if we have n elements, the total number of subsets we'll have is nothing but 2 power n. So in this case, n is 3. We'll have 2 power 3 subset, that is nothing but 8. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 subset. Now we'll try to write the sum of all the subset elements. So here we have 0. Here we have 1. Here we have 2, 6, 3, 8, 7, and 9. So these are the sum of the subset, but we know that we have to print the sum of the subset in sorted order. So our final answer will be nothing but 0, then 1, then 2, then 3, then 6, 7, 8, and 9. So this is our final answer that we have to get. Now, actually, we can solve this problem using bitset. So we'll take the help of C++ bitset to solve this problem. Okay. So to solve this problem, you should be aware of how to use bitset. So we always have to take bitset of size, which is nothing but the sum of the element plus 1. So let's say if we have this example 3, 1, 2, 6, the sum of all the elements over here is nothing but 9. So we have to take a bitset of size 9 plus 1. That is nothing but sum of all the array element plus 1. So let's take bitset of size 10. Yeah. So initially all the values in our bitset will be zeros. Yeah, before we proceed with discussing about the solution, like we can access any bitset element. Let's say the name of this bitset is BS. So if I want to access the third bit from this bitset, I can just write BS of 3. So it will give me the value which is present at the third bit. If I write BS of 0, it is going to give me the value which is present at the 0th bit, and so on. So what we are going to do right now is, let's say if we have 1 at any point of place, this means that we can make 6. If 1 is there at the position 6, at the sixth bit. This means that we can make 6 with the help of this given array. Okay, so initially if it is all zeros, we are treating that we can make none of the subset. So let's take an empty subset of size 10, that is 0 0 0 0 0 0 0 0 0 0 0. Yeah, this bit set is of size 11. It is because array index is starting from 0 all up to going up to 10. Okay, now if I say if we have no element in this array, if we don't have 1 to 6, even though we can form one set that is empty set, right? So what we are going to do is, initially we are going to keep the 0th bit as 1. This tells that we can form 0 without using any of the number in the given array. Okay, now from next step, we have to take one number at a time from the array, and we are going to do one operation. That operation is nothing but we are going to update our bit set by bit set is equal to bit set, or this is bitwise OR operation, and we'll shift bit set, left shift bit set by array of I element. So array of I is nothing but the current element. So we are going to shift our bit set for number of times which whatever is the value of the array element, that many times we are going to left shift it, and then do OR with the same element. So let's take 1. Initially we will take the first element, that is 1. Now what we are going to do is we are going to shift the bit set for one time, left shift. So now our bit set will become 0 0 0 0 0 0 0 0 1 0. And what we are going to do is we are going to perform OR operation with the same bit set. So here we'll take the same bit set, that is nothing but 0 0 0 0 0 0 0 0 0 1. Now if we apply OR, whatever we are going to get is nothing but 1 1 0 0 0 0 0 0 0 0 0. So this tells that if we only have 1, we can form two numbers. Those are nothing but 0 and 1. So if you have only one number, that is 1, what all subset you can form? There are two subsets. One is empty subset and one is of 1. The sum of these both subsets are nothing but 0 and 1. Now let's take another element, that is 2, and perform the same operation. So we'll take 2. So what we are going to do is we are going to shift our bit set for 2 times towards the left. So now what we are going to get is nothing but 0 0 0 0 0 0 0 1 1 0 0. So we have left shifted this for 2 times. Now we'll do the OR operation with the same bit set. So it is 0 0 0 0 0 0 0 0 0 1 1, the same bit set. If we do this, what we are going to get is all zeros here and 1 1 1 1. This tells that if we have 1 and 2, we can form 0 1 2 and 3. Right? If we have this 1 and 2, we can form 0 1 2 and 3. Now we are left with one more element, that is 6. So let's see. What we have to do is left shift our current bit set for 6 times. So this will come here 1 2 3 4 5 6. So finally we are going to get 0 1 1 1 1 0 0 0 0 0 0 6 zeros here, and we are going to perform OR with the same bit set. So we'll get 0 0 0 0 0 0 0 1 1 1 1. If we now do OR, we'll get 1 1 1 1 0 0 1 1 1 1 1. Yeah, so this is our final bit set, and it is telling that we can make 0 1 2 3 6 7 8 9. Yeah, so these are the values we can make. So we can make 9, we can make 8, we can make 7, we can make 6, we can not make 5 and 4, we can make 3 2 1. So wherever we have ones, those are the positions, those are telling us that we can make those values. So now if you match, we can make 0, yes, we can make 1, yes, we can make 2, yes, we can make 3, yes, we can make 4, no, 5, no, 6, yes, 7, yes, 8, yes, 9, yes, 10, no. So this is our answer. Now if we match it with the answer we wrote over here, it is exactly same, right? Now let's see how we can solve this problem with code. So what I'm going to do is, this will take the same example. I'm reading n, that is nothing but the size of the array. After that, I'm reading all the values in a vector and passing that vector to a function. This is going to tell us or print all the subset sum in ascending order. Okay, so as we see at this question, as we look at this question, it is telling that we can have bit set of maximum sum as 10 power 9, right? So what we are going to do is, instead of calculating the sum, we will take bit set of size 10 power 9. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 1. As I said, we'll give the name as BS. Yeah. Now what we have to do is, first time we have to say that BS of 0 is equal to 1. Why? Because we can always have an empty set and the sum will be 0. So it is saying that we can form 0. Now slowly we'll iterate through each element of the vector. So let's say int I is equal to 0, I less than v dot size, I plus plus. Yeah. Now how we are going to update our bit set is equal to bit set bitwise or with bit set left shift for current element time. So current element is v of I. And it will keep on updating our bit set. Finally, what we have to do is, we know that the sum can exist anywhere between 0 to 10 power 9. So what we are going to do is, let's iterate int I is equal to 0, I less than this will be equal to, as we look at the constraint, the sum can be 10 power 9. Now, wherever we see that BS of I is equal to 1, we'll say that we can form I, and we will always get the value in sorted order. Why? Because we are iterating from 0 to 10 power 9, right? So let's run this. Yeah. So what did we get? We get command terminated by signal 11. Yeah. So one thing is, we cannot run our for loop for 10 power 9 times. We cannot do 10 power 9 operation. So if constraint is 10 power 9, if the sum of the element is 10 power 9, you cannot iterate through a for loop for 10 power 9 time. Okay, so let's change this to 10 power 6. So if we change it to 10 power 6, this means that the sum of all the element is 10 power 6. Now we'll reduce 3 zeros from here, 3 zeros from here. The other way of doing is, you add all the values of the vector and declare a bit set of that size. Yeah, now you can see we are getting the same answer, 0, 1, 2, 3, 6, 7, 8, 9. This is exactly same what we discussed, right? Let's say if we have only two elements, 1 and 2, if we are getting the correct answer or not. Yeah, we are getting the right answer. We can form 0, 1, 2, 3 with the help of only 1 and 2. So if you want to look at this code, yeah, if you want to look at this code or problem statement, you can just take this link, KCIOAF, and you'll have the code available. So this problem, this code help us to solve lot of problems related to subset. Now, if somebody asks you to find if there is a subset with some S, you can easily iterate through this bit set, final bit set, and it is going to tell you if, or instead of iteration, you can just check, like after doing all the operation, if BS of S is equal to 1 or not. If it is equal to 1, you can directly say there is a subset. Yeah, thank you.